Okay, we're going to have a look at how we actually work out the units in a rate equation. I'm just going to take an example of a rate equation, very commonly seen, which is an overall third order rate equation. So the standard for the rate equation equals rate equals K, concentration of A to the power 2 times concentration of B to the power 1. This means that it's second order with respect to A and first order with respect to B. Sort of question you would then get would probably involve some numerical data, but also a part of the question that would say, can you work out the units for K? So first job would be to rearrange the rate equation. So taking care with the rearrangement, we normally find that the K, the velocity constant, equals rate divided by the concentration factors. In this case, we've got the concentration of A to the power 2 and the concentration of B to the power 1. If you go back to the table of data, you will find the units for the rate, but normally that's changing concentration over time. So in this case, I've used moles per decimeter cubed per second. We need to also know the concentration value, so those square brackets means moles per decimeter cubed. Once we put that into the value for K, we've got K equals moles per decimeter cubed per second on the top, that's the rate unit, divided by all the units for the factors of the concentration. Because it's third order, we'd divide by moles per decimeter cubed times moles per decimeter cubed times moles per decimeter cubed. Then we'd look to cancel out some of the units, so in this case we can cancel moles per decimeter cubed on the top with moles per decimeter cubed on the bottom. That means the units for K equals seconds to the minus 1 on the top divided by moles per decimeter cubed on the bottom. If we have a look underneath, we can simplify the lower part of the fraction because we've got two multiples of moles, so that will be moles to the 2, and we've got two factors for decimeters, so it would be decimeters to the minus 6. In this case then we can simplify the whole thing onto one line, so we've got moles to the minus 2, decimeters to the plus 6, seconds to the minus 1. This works because if we've got the unit 1 over moles squared, we can also write that as moles to the minus 2. And if we've got 1 over decimeters to the minus 6, we write that as decimeters to the plus 6. So overall, in a third order equation, we'd have moles to the minus 2, decimeters to the plus 6, seconds to the minus 1. What we find is we can relate the units to the overall order. So if it's a first order overall rate equation, it would be seconds to the minus 1. If it's a second overall rate equation, it would be moles to the minus 1, decimeters to the plus 3, seconds to the minus 1. A third order, like the illustration, is moles to the minus 2, decimeters to the plus 6, seconds to the minus 1. And a fourth order would be moles to the minus 3, decimeters to the plus 9, seconds to the minus 1. So in this case, we could probably work out how to establish each of the units for K, but you could see that there's a pattern there and you could learn that to go alongside your rate equations. Hopefully that would help you in working out the units, and it's over to you now to practice a few questions.